Hello students, welcome once again to our series, to our YouTube channel. See, if these videos are helpful to you, they will definitely be really very helpful. Okay, that one thing I can definitely assure. But still, if you feel that they are helpful, so please do like the video and just subscribe the channel. Okay, let's move ahead. See, we are already done with the straight line. One practice session for the mains level question, one for advanced, and then two practice sessions for circles main level question. 20 questions we have already done. Now today we are going to move ahead with the circles advanced level questions. Okay, so now let's move to the first question here. The first question is, let C1 be the circle. And one more thing I will like to say here, that please do try to attempt the question which we post a day before, or at least 8 to 10 or 12 hours before releasing the video solution. Okay, so please do try to attempt the question before watching the solutions. And if you are not getting the you are new to the channel, so then again I will try to suggest you that the question is of course in front of you before I solve it. So just pause the video, try to attempt the question, and then move ahead. If you need any help, then only go for the solution. If you think you are done, then move to the next question. Okay, so let C1 be the circle, which is this one, whose center is 0, 4, radius is 12. C2 is another circle whose center representing C1 and C2 as a corresponding centers, whose center is x minus 3 whole square plus y square is equal to 13, and A and B. Okay, they meet at A and B, bachon. So two circles intersect at A and B. So that's it. So that's it. Now, a quadrilateral ACBD is formed by tangents at A and B. So let's say this vertex is A and this point of intersection is B. So the quadrilateral formed by the tangent. So draw tangent to it, one circle, draw tangent to the other circle at the point A. Similarly, draw tangent to one circle at B and the other circle at B. So A, maybe C, B, D is a quadrilateral. Then the length of diameter of the circumcircle of this quadrilateral ACBDC. When I started solving this question, the first thing I tried was, can we find out any special relation between the circles? See, that's one thing I always try. Okay, before moving ahead and thinking something in terms of general relation or general result, whatever it is. But now, see, so what I found, the distance between, I must be thinking something. Okay, so that's the center and the radius. Okay, so I have to write the center is 3, 0, and the radius is 13 here, rather root 13, root 12. Okay, now distance between centers C1, C2, how much is it? It's 5. Distance between center is 5. Okay, now if I say R1 square plus R2 square, how much is it, bachon? It's 12 plus 13 is 25, which is nothing but DC1 C2, distance between center whole square. What does that mean? What does that mean? That simply means that the triangles are, that the circles are orthogonal circles. Okay, do you remember that? So what does that mean? See, if two circles are orthogonal, what does that mean? That means they intersect at right angle. Then the only possible condition is that the tangent to the one circle has to be the normal to the other circle, and vice versa. Okay, that's for sure, because then only distance, this angle is 90, and this is the distance between the center. So R1 square plus R2 square is equal to C1 C2 whole square. That's it. Okay, so that's what we got here. So distance between center whole square is nothing but sum of the square of radii. So what does that mean? That means this angle is right angle. So that means this point is, let's say, C1, this is, let's say, C2. Okay, so now again, what does that mean? That means, so if we draw this common chord, and see, we know that, let's consider this circle only, this circle whose center is C2. Okay, now from an external point, if we draw two tangents to a circle and we try to find the circumcircle of the triangle formed by the external point or by the tangents and the chord of contact. So just forget the first circle here. CAB is a triangle, or CAB is a triangle. So if you want to draw its circumcircle, the property says it always passes through the center of the circle to which the tangents are drawn. Okay, so I would have discussed this property in my earlier videos also, but I am repeating here. So the property says, so if you want to draw the circumcircle of this triangle, which triangle? The triangle formed by the tangents and the chord of contact, that will always pass through the center of the circle to which tangents are drawn. So that simply means that the circumcircle of the quadrilateral ACBD is nothing but the circumcircle of the triangle ABC, which has to pass through the center of the other circle. So that simply means that the diameter of this circle is nothing but the C1 C2 distance, which is 5 units. So the answer is 5 units here. Okay, so just an observation using the given information after observing that the tangents are passing through the centers of the other triangle. Why? Because they are orthogonal to each other. So that was the first question here. Moving to the next question. Second question is, suppose ax plus by plus c equal to 0, where a, b, c are in AP, be normal to family of circles. Okay, now see, family of circle means there are infinite circles. Now when the same line will be normal to all the family of circle, it is possible only when it passes through the point of concurrency of all those lines. Okay, that passes through the center of all possible circles. That's it. So these are, again I will say, these are infinite lines. A, B, C are in AP. That means I can replace b by a plus c by 2. So what I will write here, I will be writing other way around this. So a minus 2b plus c equal to 0. So if you compare these two, so you can say x is 1 and y is minus 2. All of you agree or not, bacho? Now what does that mean? That means this equation, this line, this variable line passes through a fixed point, and the fixed point is 1 comma minus 2. So that means all infinite lines passing through the same point, and since all the lines are like normals to the family of circle, what does that mean? That means you have a family of circle with the same center, and the center is nothing but this 1 comma minus 2, because then only you consider any member of this family and any line of this family, ax plus by plus c equal to 0. Every line will be a normal to every circle of the family. I think you people got it. Okay, so all the members of this family has center as 1 comma minus 2. Fine. Now the equation of the circle of this family which intersect the given circle x square plus y square minus 4x minus 4y. So x square plus y square minus 4x minus 4y minus 1 equal to 0 orthogonally, right? Now center of this circle is 2 comma 2 and radius is 3 unit. Center of any circle of this family is 1 comma minus 2. So the circle which we need is one among those circles of the family, so having same center. Let the radius be r to be r here. Now again I will be using the same geometrical property here, but what is it? Again I am repeating, the sum of square of radii is nothing but distance between the center. So sum of square of radii is 9 plus r square, and distance between the center is nothing, square is 1 plus I think 16, bacho, right, 4 plus 4 16 9. So r square is 17 minus 9 is 8, so r is 2 root 2. Okay, so the circle is let's do it. See, one among them, so that you can check out, 1 comma minus 2. So 1 comma minus 2 is a possibility here. I think that should be the answer, 1 comma minus 2. Okay, and then when you write it, so it is that so? 1 comma minus 2 is the possibility only in this case. In this case also, you can check it. Yeah, that should be the answer. A1 should be the answer, because radius has to be 2 root 2. So 4 plus 1 5 plus 3 is 8. Yeah, A part is the answer. So that's the question. So that was an interesting question. That's why I selected for you people. Now again, two circles with radii R1 and R2. R1 is greater than R2, which both are greater than equal to 2, touch each other externally. So two circles with radius R1 and R2 touch each other externally. Okay. If theta is the angle between the direct common tangent. Now what are direct common tangents? The direct common tangents are the tangent for which both the circles lie on its same side. So like this, or the other one will be like this. So the angle between the direct common tangent is given to be theta here, bacho. That's it. Then we have to find sine theta or maybe sine theta by 2. Okay, so if you write it in that term, so it's sine theta by 2 is equal to whatever you have here, or you write it like this. So it's sine theta is equal to whatever you have here. That's what we have to find here. Okay, now see, again, that's an important interesting question here, bachu, and reason I will tell you. There are so many properties which I will be using here, and you all need to remember and know those properties. So that's the basic reason of discussing this question here under this in this session here. See, r1 is greater than r2, so of course this has to be r1 radius, and then this is r2. If I call this point of intersection as A, this point as P, this point as Q, C1, C2. Okay. Now, I'm going to use similarity of triangles here. Which two triangles seem to be similar here? Of course, you can say this angle is of course theta by 2. I think all of you will agree with you. Why? Because you can very easily prove that if I call it as R, triangle APC2 and triangle ARC2 are congruent triangles. Okay, the simple radius common and the tangents are equal. SSS, side criteria. Okay, so this angle is half of the complete angle, which is theta, so theta by 2. Now let's come back to that point. So I am claiming that triangle APC1 is similar to triangle AQ, it's C2 I think, AP, just a minute, C2 is similar to AQC1. Okay, now again, how? Angle criteria. This is 90, this is 90, and one angle is common. So if two corresponding angles in two triangles are equal, then by angle criteria the triangles are similar. Okay, now if two triangles are similar using CPSC, corresponding parts of two similar triangles, what does it say? That the sides are, the ratio of the corresponding sides is equal. Okay, so I will be writing here that AP is to AQ is equal to R2 is to R1, isn't that? Now AQ is larger than AP, so I will be writing its reciprocal R1 by R2. Now why am I writing it? Because I will write AQ as AP plus PQ by AP is equal to R1 plus by R2. Now this is of course 1 plus PQ by AP is equal to R1 by R2. Take one that side. So now what are we left with is PQ by AP is equal to R1 by R2. Now that's done. Now the problem here is PQ. Now what is it? PQ is the length of common tangent. Now that's again one of the reasons why did I pick up this question for discussion here. We need to remember this formula also if you can do it, and the result is, see, for two, now I'm doing it for general case. So if these are two non-intersecting, non-touching the circles, and this is the length of tangent, and this is distance between center D, and of course this is R1 and this is R2. So if I'm not wrong, then L, the length of direct common tangent, that's the case here, is nothing but under root of D square minus R1 minus R2 whole square. Okay, and if this would have been the transverse common tangent, now which tangents are transverse common tangent? For which the circles lie on its opposite side. So this is LT. So transverse common tangent, its length. So that formula will be under root of D square minus R1 plus R2 whole square. Just keep these two results in your mind. I am going to use it now since, see, we are given that circles touch each other externally. What does that mean? That means distance between the center, which I am representing as D, in that result is nothing but R1 plus R2. So the length of this direct common tangent PQ is nothing but under root of R1 plus R2 whole square minus R1 minus R2 whole square upon AP, which is R1 by R2. So you got here AP, bachu, and what is it? So this is nothing but R1 square plus R2 square term will get cancelled 2 times under root of R1 R2 into R2 by R1. So how much is it? So that's AP, just a minute. So it will be 2 times under root of R2 by R1. Okay, wait, there's a mistake, just a minute. Yeah, 1 has to be that side. Okay, I think you people would have noticed it. How can I notice it? Why? Because see, the result which I got was not somewhere matching with this one. Okay, so just a minute. So that gives us AP, so this is nothing but R1 minus R2 upon R2. Okay, so wait, we need sine theta by 2. So let me write here sine theta by 2, because once we have sine theta by 2, we have sine theta and cos theta everything, and we need sine theta by 2 here also. So sine theta by 2 is nothing but R2 upon AC. Okay, so it's R2 upon AC. Okay, and AC is R2 square plus AP square. Oh, it got lengthier, no? Somewhere I think I went in some different direction, because when I solved it, when that question I got it as a doubt, I got it in first stroke. So you people can check it. Meanwhile, I'm just trying to complete it. So AP is this is 2R1 R2 2 times under root of R1 R2 into R2 upon R1 minus R2. Okay, R1 square plus this square. Won't that be a bit too lengthy, bacho? Just a minute, let me check. So AC is under root of R2 square plus AP square. So AC is under root of R2 square plus 4R2 square R1 R2 by R1 minus R2 whole square. Even if I take R2 common, okay, so if I take R2 out of it, then we have R1 minus R2 whole square plus 4 R1 R2, right? At least we got something like R2 plus R1 upon R1 minus R2, right? So a bit simple one. So sine theta by 2. So I think we may get it in few lesser steps, because that day I got it in few lesser steps. Okay, now I think we got it because sine theta by 2 is nothing but R2 upon AC, which is R2 into R2 plus R1, so R1 plus R2 into R1 minus R2, and that should be the answer. So that means theta by 2 is sine inverse of R1 minus R2 upon R1 plus R2, and then it is like 2 times this. So that's an option, that's the answer. That's the answer. So finally we got it. So the important aspect in this question was the use of length of direct common tangent, and hence I told you how to get the length of the formula for the length of transverse common tangent also, and I mean few geometrical properties. So that was the importance of this third question. Moving to the fourth one. Fourth question is, let BC be the chord of contact of tangent from point A to the circle. If P is any point on the arc BC, let Px, Py, Pz be that length of perpendicular. See, that's a very lengthy question. Okay, so I will expect that you people will complete it. I will tell you how I tried. I couldn't get it in a general term. It really got very lengthy. So what I did was I just took it as a special case. So like I just took one point here, and let's say the point is maybe P comma 0. Tangents are drawn from this point. I think this point is A, if I am not wrong. Let BC be the from point A, right? And BC is the chord of contact here. So BC is this chord of contact. So this is B, this is C, and from any point on the arc BC. So that's your arc BC. So consider any point here on the arc BC, and then perpendicular drawn from this point to these are, like this is, let's say this is X, this is Y, this is Z. We have to find a relation between Px, Py, Pz. Are they in AP, are they in HP, or are they in GP? Now see, how I approached to just complete this question was, see, with respect to this point, I am assuming that P comma 0 is a given point. Of course, A is a given point. Okay. Then BC. So capital T equals 0. So equation of circle is x square plus y square minus 1 equal to 0. Okay, so equation, this is a chord of contact whose equation is capital T equal to 0. So writing capital T is a simple thing. It's going to be a vertical line. So it is like Px minus 1 equal to 0. So that's your PC. That's your line equation of line or chord of contact BC. Now how will you get the equation of tangent? Because then only you can have the length of perpendicular drawn from any point. Okay, now see, for that of course we can write the equation of tangent to the circle in standard form is y is equal to mx plus minus r, which is 1 under root of 1 plus m square. Now make it pass through P comma 0, you will get m. two different values of m, because you are going to get a quadratic. So this is 0, so it is Pm is equal to under root of 1 plus m square. Squaring, since I have to square, I didn't take care of putting plus minus, just square it. So p square m square is equal to 1 plus m square. So hence we got m square as take it that side, so maybe 1 upon p square minus 1 bacha. Okay, so m is 1 upon under root of p square minus 1 m1, and m2 is 1 upon minus times under root of p square minus 1. Now you have equation of tangent passing through this point with the slope. You have three lines. Now let this point be, of course this point is on the circle, so it can be cos phi sin phi. Okay, now get the length of perpendicular drawn from a point to the line, and when you will multiply, I mean py square, see that's what you need, you will get py, px, pz. You have to see that 2 times py is px plus pz, or py square is px into pz, whatever it is. So whichever relation it satisfies will give you the answer. So I am telling you here that the answer is gp. Okay, so py square has to be equal to product of px and pz. So if any student has, see that's a very raw, crude method which I did, using which I could complete this question at least. See, the primary like objective is to first complete the question, so I could complete it. But then I tried to use so many things like geometry, maybe area, sums. I tried few things at least, not so many things. See, one thing I tried was that I will share it, like writing this, completing these triangles. And then see base into height, base into height, base into height, then like adding these three triangles area with the area of the triangle ABC. But then there was a problem, I couldn't get rid of the side AB or BC, and then if those can be taken care of, then this angle, so I couldn't get rid of that thing. So I got stuck. So then I went back to the very basic, as I said, crude method to complete this question. Okay, so again I will repeat, if anyone has any better method, so do let me know. I will definitely appreciate it and learn something out of it. Okay, a circle with radius a and center y-axis slides along the y-axis, and a variable line passing through a comma 0 cuts the circle at points p and q. Then the point of intersection of the tangent to the circle. Okay, right, see the situation is, there's a circle, I mean a circle which is sliding down along the y-axis whose radius is a unit. Now there is a line passing through a comma 0 which intersects circle at 2 points p and q. Tangents drawn at p and q intersect at r. Okay, now the point of intersection of tangents to the circle will lie in the region defined by. Okay, so now, so of course this is a variable point here for me, I mean that's a which is varying, of course, as it will slide down, this point is going to change. Okay, so we have to just find the region in which h comma k lie, the region which h and k satisfy. Okay, now see, of course, as you can look here, you can observe here in the figure that actually one thing you all would have observed, that by solving the question of coordinate geometry, the first step, the very first step is to draw the figure. I'm not missing it because that's in my practice. I mean I don't start solving a question of coordinate geometry without drawing a figure, because at times figure really help us. Like looking at the figure, now we know that this is nothing but the chord of contact to the circle with respect to this point. Okay, now let's say this center is 0 comma b. So equation of circle is x square plus y minus b whole square is equal to a square. Now equation of chord of contact is capital T equal to 0 with respect to hx. So it's so let just complete it. Plus b square minus a square equal to 0. So capital T equal to 0 with respect to hk. So hx plus ky minus b times y plus k plus b square minus a square equal to 0. So that's the chord of contact, but one relation is given here for the chord of contact, and that passes to a comma 0. So just satisfy, replace x and y by a comma 0. So we get ah that's 0, y 0 minus bk, and then plus b square minus a square. See, for a moment I just got stuck here that what to do, but then I realized that b, since the circle, see there's one thing which very first incidence I missed, that circle is sliding, that means circle is not fixed, that means b is a variable, b is a variable, A is fixed. Okay, so B is a variable and B has to be a real number because it is ordinate of the center of the circle. It has to be real. So then I realized that okay, let us use here the condition for real roots of a quadratic in B, and that is D greater than equal to 0. So that gives us a region. So B square, I mean the coefficient of B whole square, which is K square minus 4 times AH minus A square is greater than equal to 0. So Y square, replacing K by Y and H by X, that's what we do, isn't that? Minus 4A or greater than equal to 4A X minus A, that's it. So that should be one of the option for sure. Which one? I think that's the answer. Okay, so that was again a different type of question. Fine. So because there are two things which are varying. I mean, when circle is coming down, okay, so we need to understand that the center is one thing which is varying, okay, which is changing, and of course the line passing to a comma 0, only one thing, the point to which the line pass is fixed. Otherwise the slope of the line is also changing here. Okay. Now, moving to the next question, two distinct chords of the circle drawn from the point gets bisected by the y-axis. Then, see, this is a very, I will say not very, but a common standard question. But still I selected it because it's an important question. Okay, it tells us how to approach such type of question, and it tells us also that whenever we need we are given or we need or we have to use anything related to the midpoint of the chord, we shouldn't forget T is equal to S1. It can be really very helpful, though as I always tell to my students that in case of circle we may have an exception. I mean that T is equal to S1 it can be a relation, can be a result which is dispensable. Without that also we can use this information, midpoint of the chord, using geometry of the circle. But had this been the question of parabola, ellipse or hyperbola, I will say that T is equal to S1 is indispensable. We have to use it. Okay, so I'll be using that thing only. So to two distinct chords of this circle, the center of circle is 1, 2 and radius is root 5. So I don't think we need it. Draw from the point A comma B. Okay, so point A comma B. So let's say this is point A comma B, and that's P. Okay, and which are bisected by I mean, doesn't seem that this bisecting it. Actually, I just focused on this one. Okay, it seems to be bisecting it. So let's say that okay, this is also the. So there are two distinct chords which are bisected by the y-axis, bisected midpoint of the chord. Okay, now I will start my solution from here only. So that's the y-axis for us. Okay, that's the x-axis. That's origin. Okay, so this is like 0, what shall I take? P. Fine. Now this is midpoint of the chord to the circle, and the circle is this. So I will say the equation of chord whose midpoint is 0, P is we know T is equal to S1. So what will that give us? It will x into 0 is gone. So Py minus x plus 0, and then minus 2 times y plus p is equal to S1. S1 means replace x and y completely in the equation of curve by the coordinates of the point. So replacing x by 0 is 0 gone, p square, and then minus 2 0 gone, minus 4p. That's it. That's it. There's one more information which we are still to use, and that is the chord passes through the point A comma B. So that means this chord should satisfy this point, the coordinates of the point which is A comma B. So replace y by b and x by a. So this is minus a plus pb, and then minus 2b minus 2p is equal to p square minus 4p. So let us now write it. Now see, how many such points we need? The midpoint of the chord. We need exactly two such points because there are two distinct chords. So hence two such midpoints. So what does that mean? See, we got a quadratic in P here. So there has to be two distinct roots of P, and that's it. So we are again to the similar situation as in the previous question. Discriminant is greater than, not equal to 0, just greater than 0. So let us write it as a perfect quadratic. So P square minus 4p minus p. So minus p common, b plus 4 if I'm not wrong here. Yeah, and then a plus 2b. Okay, wait. Minus 2p is also there. Okay, so instead of my 4, it is 2. Just a minute, Bacho. Yeah, it's 2. And then it is a plus 2b. equal to 0. So that's a quadratic in P, and we need two distinct rules. So B square is greater than 4AB. That's it. So let's say if B plus 2 whole square is greater than okay. So B square plus 4B, okay, minus 8B. Fine. So B minus 2 whole square is greater than 4A. So that, I think that's a condition. B minus 2 whole square is greater than 4A. So that should be the answer. Okay, so that was question number 6 here. Moving to next one. Next question is, P and Q are two fixed points. R is a point such that PR is equal to NQR. Then the common properties of locus of R for different values of N. See, one thing we need to understand, that whenever we have such a situation, PR by QR is equal to N. Okay. It's like that R is a variable point, P and Q are two fixed points. That's what we are given. Okay, and the ratio of the distance of R from two fixed points is a constant, and that constant, of course, since this ratio of distance, it has to be positive, is not equal to 1, because if it is equal to 1, then we get, if you remember, equation of perpendicular bisector of segment PQ. Okay, so why so? Because see, if PQ is a fixed given line segment and perpendicular bisector, the property of perpendicular bisector is any point on the bisector is equidistant from the end points of the segment. So if PR is equal to QR, we are going to get a straight line, and that straight line has to be the perpendicular bisector of the segment PQ. But if it is anything else, not equal to 1, less than 1 or greater than 1, we are always going to get a circle. We are always going to get a circle. Okay. So now, and then the common properties of locus of R for different values of N. See, they haven't said anything about the N, whether it's a whole number, can't be whole number, it's a natural number, integer, nothing of that sort. So it has to be just a positive real number which is not equal to 1. Okay. So now see, PR is equal to NQR will always be a circle for N not equal to 1. Always and always, and you can easily check it. See, let's say P is nothing but alpha beta, Q is nothing but gamma delta. Okay, so P and R is the variable point x comma y. So just apply the distance formula. We don't need to do so much of calculation here. It's really very simply and directly visible here, squaring both the sides, and then it's x minus gamma whole square plus y minus delta whole square. And now look at it, bachon. See, collect the terms. See, there. So x square, and that is, so the coefficient of x square is 1 minus n square. Similarly, the coefficient of y square is 1 minus n square, and is there any possibility of having a term of form x into y? Answer is no. So what's the condition for any second degree equation to be a circle? The simple conditions are the coefficient of both x square and y square should be same, and there shouldn't be any term of x into y, and of course the radius under root expression g square plus f square minus c should be greater than 0 or equal to 0. That will be the case here. Okay, so that's it. So if you just do it, so that's always a circle for n not equal to 1, because if n 1, these two terms are gone. Okay, so that's always a circle for sure. Now the point is, let's go to the option. The option first, locus of R is a family of circle. Of course, for different values of n, you will get different circle, hence a family of circle with diameter less than PQ. Now that's the one thing we need to check. So how I try to check it, I just tried. One more thing I will try to tell you all here. Let's see. If I am writing PR by QR is equal to N, and N is, let's say, greater than 1. See, for any circle which you get from here, it will contain only one point among P and Q. I mean, that, what does that mean? That simply means exactly one point will lie inside the circle and other one will be outside the circle. How can you decide it? If N is greater than R, so N is greater than 1, that means the distance of R from P is always greater than its distance from Q. Okay, so that means that has to be the circle. So Q is inside and R is outside. So if it seems that if it seems that Q is the center, so we are mistaken. So I just changed the figure in that case. Okay, to keep it a general result. Okay, now see, this is R. Why? Because of course this ratio has to be n is to 1. So hence you can get R, this point where it intersects the line segment PQ, and when you extend PQ, this is another point. So if this is R1, this is R2, and then again R2 again divides the segment PQ externally in the same ratio n is to m. What does that mean? You have the coordinates of both R1 and R2, and I've already proved it years back, but I've already proved it. Okay, so I know it and I'm just telling you, in that case R1 R2 has to be the diameter of the circle R1 R2. So PQ segment when extended will always pass through the center of all such possible circles बच्चों, ठीक है. Now so it's always a family of circle. Now see, to prove it what I did, I mean related to center, so either we go for the coordinate form, but I preferred here the vector form. Okay, so I just assume the position vector. I believe you all know it, isn't that? So position vector of point P is given by vector P, and position vector of point Q is given by vector Q. So we can have this. So this is nothing but n vector Q using like section formula n plus 1. Similarly, this will be n vector Q minus vector P upon n minus 1, external point of division. Now I just try to write R1 R2 vector. Okay, so this is that minus this, or this minus that, whatever you wish. So I just wrote it as nq plus p upon n plus 1 minus, see, ultimately I have to take its magnitude. Why so? Why? Because I have to just compare the distance, I mean the diameter thing, R1 R2 length with the length of PQ. So what did I get here? npq minus p upon n minus 1 now. So therefore this implies length of R1 R2 vector is, now just for simplified, so under root of this is in denominator n square minus 1, in numerator it will be n, चलिए कर देते हैं, n square q minus nq plus np minus p minus n square q, then minus nq plus np plus p, isn't that bachcho? So p and p got cancelled, n square q got cancelled, so it's okay, 2n is common, so R1 R2 is 2n is common, p minus q upon n square minus 1. Now that's it. Now p minus q is nothing but length of PQ. Now my point is that it can be greater than PQ also, it can be less than PQ also, isn't that? See, if I take n as 2, a simple case, 4, so it's 4 by 3 times, 4 by 3 is always greater, I mean obviously greater than 1. So PQ and R1 R2 distance, the diameter is greater than, but if I take any other number greater than 2, I mean if I go for natural number only, let's say 3, then it starts getting smaller and smaller than PQ. Okay, so that's it. So this is one thing. So both the possibilities are there. I mean they haven't said anything about n, whether it's a natural number or not, so n can be as good as half also. It could be half also. So then again we will get something which is maybe greater than PQ. So that's it. So I mean, so first option, though there's a relation between the length of the diameter and the distance between PQ, but somehow this is not always true. Then the locus of R is a circle, and for different values of n, all the circles have a fixed radical axis. That you can try. See how you can try here, because see, if I divide this by, see, that's a family of circle for given like n, for given n. So if I divide it by 1 minus n square, so that's a function of 1, and that's a function of n, that's a function of n. So for two circles, I mean for n1 and n2, if I subtract them, and then if you have a line which is independent of n1 and n2, then you have the answer. Okay, and if it's not the case, just a minute bachcho, and if it's not the case, then you may say that it is not the just a minute answer here. So do not disturb, wait bachcha, right, okay, sorry. So that we have to check. Okay, so in any case, so when I tried, I again didn't get any of these answers, so my answer is none of these. Okay, because of that one case where I found that the diameter can be greater than PQ also. That can't be the answer. I just proved it in front of you. And for the two different values of n, when you find the equation of radical axis, which is S1 minus S2, I didn't get a relation, a line which is independent of N1 and N2. Hence, radical axis is also not fixed according to me. So just check it out quickly. Okay, once you are completing it with me, and then you can tell me. So my answer is none of these here, bacho. Okay, now moving to the 8th question. The equation of a circle which cuts the circle orthogonally. See, again an orthogonal circle. The point at the point, okay, so that's a circle, x square plus y square is equal to a square with center as 0 comma 0, and such that the slope of their common chord, okay, the slope of common chord is -1, and it passes through the of course a root 2 by a root 2. So I can have the equation of this common chord. How? Because when two circles intersect each other, the equation of common chord is S1 minus S2. I'm not going to use it, but I just told you, because getting equation simply point slope form. So y minus a by root 2 is equal to minus times x minus a by root 2. So it's x plus y is equal to root 2a, if I'm not wrong. Isn't that, bacho? Now see, I will write equation of all possible circle that passes through the point of intersection of this line, and this circle, and what is it? It is s plus lambda times line equal to 0, and the equation of circle is x square plus y square minus a square plus lambda times line is x plus y minus root 2a equal to 0. Okay, so that's the all possible circle which passes through these 2 points, and all possible circle which passes through the point of intersection, of the line. This is the line which is common chord, and this is the circle. Okay, now the required circle which is orthogonal to the given circle is also a part of this family. Okay, so what does that mean? So I will write it in a perfect form, x square, perfect equation of circle form, lambda x lambda y minus a square plus root 2 lambda a equal to 0. So now for orthogonality condition, so center is minus lambda by 2 comma minus lambda by 2, and the radius is under root of this square plus this square is lambda square by 2, and then plus a square plus root 2 lambda a. Fine. Now two circles are orthogonal. We have already used it. Sum of square of their radii is equal to distance between the center and distance, and since the center was 0 comma 0 and the radius was, I think, a, radius was a, so square them and c1 c2 whole square. What do we get? So c1 c2 distance whole square is lambda square by 4 plus lambda square by 4, and square add a square plus lambda square by 2. See, issue is so helpful, no? That's gone. A square is so a gone. So lambda, so 2a minus 2a is equal to root 2 lambda. So lambda is nothing but minus root 2a. So therefore, equation of circle, you have to just replace lambda by minus root 2a. So it's x square plus y square. So you may just simply complete it, isn't that? What, equal to 0. So whichever option satisfy it. So minus a, these are two options that you can check whichever satisfy the relation. Okay, so that was yet another question, a different form. Orthogonality condition, and the equation of family of circles was used, and the equation of common chord was used. Okay, so in a different format, so that's why I picked up this question. Moving to the next one. Next one is C1, C2, C3 belong to a family of circles through the points x1, y1, x2. To prove that the ratio of length of the tangent from any point on C1 to the circle C2 and C3 is a constant. Okay, again quite a lengthy one, but still I selected it because see, we should be ready to deal with a lengthier question. Of course, no one is going to ask you to prove that it's a constant, to show that this happened, but still, see, for me, as I always say, question is a question, whether it appears in the form of objective question, single correct, multiple correct, matrix match, assertion, reason, true and false, fill in the blanks, integer type, non-integer type, subjective, doesn't matter. Question is a question. Okay, first thing. Second thing, of course, we should be ready to tackle, to come across a very lengthy question also, and then see, advanced is a bit more low scoring paper. So the important thing there is to crack the question. Okay, so here see, I didn't use anything anything very out of box, because of course I'll be using the equation of family of circle passing through two given points x1 y1 and x2 y2. Fine. So what is it? So equation of family of circles, equation of family of circles is x minus x1, if you remember बच्चों, rather see the circle which we consider is here, which is what's the circle? The easiest possible circle is for which AB is the diameter, and for diametric form we know it's x minus x1 into x minus x2 plus y minus y1 into y minus y2 plus lambda times equation of the line. And equation of line in this form is what is it? Wait. X minus x1 and then y minus y1, x2 minus x1, y2 minus y1. Isn't that? Evaluate it. So y minus y1 is equal to y2 minus y1 upon, if I cross multiply, what will we get? X minus x1 into y2 minus y1 is equal to, rather minus, equal to y minus y1 into x2 minus x1. Okay, so if I bring it this side, yeah, that's it. So that's the equation of line, right? So see, why am I trying to write it here? Because I knew it can be written in determinant form, and that's why I just wrote it for you people. I mean, you should also try to remember it. So circle and line. Okay, now there are three such circles, C1, C2, C3. So let's say C1 is the circle which is there for let's say so if I call this expression as maybe just a minute, f of xy, and this one as L of xy. Okay, so function, fine. So it is f of xy plus lambda 1 times L of xy equal to 0. Similarly, C2 will be f of xy lambda 2 times L of x comma y. C3 will be, for three different values of lambda, we have three different circles. Now these are three circles, so lambda 1, lambda 2, lambda 3 are assumed to be known numbers. Then only we have known circles, three given circles, C1, C2, C3 of this family. Now the question is that from any point on this circle, let the point be h comma k. So let, or point A be a comma b. Okay, so that means f AB plus lambda 1 times L AB is equal to 0, because point is on the circle 1, it should satisfy its equation. So x to be replaced by abscess of the point and y to be replaced by its ordinate. Now equation length of tangent from point A comma B to C2 is given by under root of S1. Remember that, bachcho? And what is it? Under root of S1 means you have to just replace the x and y in the equation of the circle by A and B. So let's say this length is L, no, let's not use L, tangent T. So let's say this length is T1. Tangent drawn from the point on the circle C1 to the circle C2. Okay, so it is under root of S1. Now how will you get S1? Again I am repeating, by replacing x and y by A and B. So if it is FAB plus lambda 2 times LAB. Similarly, length of tangent T2, length of tangent to C3 is again root S1. So I am calling it as T2. So T2 is under root of FAB plus lambda 3 times AB. Now what we have to prove here in this question, we have to show that the ratio of this length of tangents is a fixed number. So we have to show T1 by T2 is a constant. So let's try, because we know so many, a few things at least here. So it is lambda 3 and lambda 2 L AB root upon under root of FAB plus lambda 3 times LAB. That's it. Now see, I'll be using this thing here. From here we know that FAB can be replaced with minus L lambda 1 LAB. So put it here. So T1 by T2 is, so it is, so of course putting within the same, so LAB is common in numerator and we get it as lambda 2 minus lambda 1. Similarly, LAB will be common in denominator also, and you will get lambda 3 minus lambda 1, and see, they get cancelled. So what do we have? So we have that as the result. So as I said, since C1, C2, C3 are the known circles, hence lambda 1, lambda 2, lambda 3 are the known constant. Hence this ratio is a constant ratio, and hence the answer. Okay, so that's how we can approach it. Otherwise it is going to be really lengthy if we go with the complete expression, like every time using x minus x1 whole square or whatever we use. Okay, it's going to be lengthy. So that's it. So that was an interesting question in that case. Now moving to the second last question. Let R1 R2 represent the radii of the smallest and the largest circle passing through a comma 1 and touching the circle. So circle is x square plus y square minus x plus 2y minus 31 by 4 equal to 0, whose center is half comma minus 1 and whose radius is under root of 1 by 4 plus 1 plus 31 by 4, 31 by 4, 32 by 4, 8, 9, 3. Okay, that's great. So radius is 3, center is this. Now touching the, see, you have to find R1 and R2 represent the radii of the smallest and the largest circle that touches this circle and passes through the point a comma 1 by a, where a is the least possible value of the ratio of side length, not the side length they have given, but that's how we use it, sides of the regular and sided polygons inscribed and circumscribed in a unit circle. Then we need the value of the sum of these radii, the smaller circle and the larger circle radius. Now the question is, that's the circle, there's a point, we don't know whether it's inside the circle, outside the circle. See, before using the method, first I try to use the method, but while using the method, while trying to solve it, okay, the one thing struck my mind, and what was that? It was, if the point is outside the circle, okay, then the smallest possible circle that touches the given circle is fine, that's just, but largest possible circle, do we have any limit about it? I don't think so. Okay, passing through this point and touching this circle, there can be infinite many circles and the radius can be as large as possible. Okay, so there's no point of asking R1 plus R2. So then I thought that if the point has to be inside the circle, and once it is inside the circle, the answer is very simple and clear. The smallest one is like this and the largest one has to be this, and the answer has to be in that case the diameter, because if two circles touch each other, the line joining their centers always passes through the point of contact. It has to be the diameter. Okay, isn't that? So the answer is the diameter. Okay, so R1 plus R2 is twice, is 6. So R1 plus R2 is nothing but 3. That's the answer. Okay, but then okay, without even solving the second part, but then let's move to the second part, where a is the least possible value of the ratio of the side inscribed and circumscribed in a circle. Today my mobile is not getting in silent mode, no? I tried it, but I don't know. See, so if a regular polygon is inscribed in a circle, okay, we have to find the ratio of their side length. So that's the center, okay, that's the angle, this is 2 pi by n, and that's your radius, and radius of the circle is 3 unit. Yeah, just a minute, this is 3 unit, bachcha. Fine. Now we have to find this side length, so just draw this, and then this is 2 pi by n, this is pi by n, Okay, we have to find this, and we know perpendicular drawn from the center to the chord bisect the chord. Okay, so this is just half of it. So if this is, let's say, small l, and then L by 2 by 3 is sine pi by n. Okay, so L is 3 by 2 sine pi by n. Bachcho, isn't that? Now for the outer the polygon that circumscribe it, the regular polygon, for that case also, if we go with this thing, again the same logic, every side will subtend the same angle. It's a regular polygon at the center, so this is again 2 pi by n, and draw this perpendicular, and now this is nothing but the radius itself, 3, and this length is capital L. Okay, and this angle is pi by n. So this time applying tan pi by n, which is opposite side, L by 2 by this 3, it's 6, no? That's 6, I'm sorry. And here also it's 6 tan pi by n. Okay, now what do we want? Wait. Polygons inscribed and circumscribed. So L by capital L is 6 sine pi by n over 6 times tan pi by n. 6 gone, it's cos pi by n, and see, they have given that n is greater than equal to 3, and of course n has to be a natural number inside that polygon. So for 2 the minimum value is 0, and see, cos is a decreasing function from 0 to pi by 2, or increasing function in the reverse order. So as you go on decreasing the value of the angle here, or increasing the value of n, cos value will increase. As you take n to infinity, it will be cos 0, which is 1, the maximum possible value. Okay, so for the least possible value, n has to be 3. In that case, this is nothing but, this ratio is nothing but half. So the point is nothing but half comma 2. The point is half comma 2, and then you can put it whether it's inside or outside the circle. It has to be inside the circle. Okay, so that's how I use it. So moving to the last question of the sheet, and the last question is, a circle touches a rectangle ABCD. Okay, of side length 2A and 2B at M and N. Okay, so A, B, C, D. So 2A, so this is 2A comma 0, so it is 2A comma 2B, this is 0 comma 2B, and that's it. And a circle touches the AD and AB and AD at C, and passes through the pointers. So let me try to draw the figure. Something like this. This is M, this is N, and passing through it. Okay, doesn't seem to be a circle, but let's adjust to it, accept it. Now see, how did I do it? Again, first I tried it using something related to the geometry, but then I will accept that I couldn't complete it. Okay, so I just switch on to geometry and the coordinate geometry, pure geometry and the coordinate geometry, on and off, depending whichever suit me. So here I then found that, see, using the property, this is tangent, perpendicular to the tangent at point of contact passes through the center. Similarly, this is tangent, perpendicular to M to the tangent x-axis passing through the point M, passes through the center, the line. So this is center. Okay, and the coordinates are r comma r, because this is also r, this is also, in that case this is also r, this is also r. So this point is r comma 0, and this is 0 comma r. So that means equation of line Mn is x by r plus y by r is equal to 1. So x plus y minus 2r equal to 0. Now distance of this line from the point C, vertex C, perpendicular distance, is nothing but given to be, is the perpendicular distance of the line from it's of course from point C is 6 centimeters. So this is 6. So we know perpendicular distance of a point from the line, and this is 6 is equal to 2a comma 2b. So 2a plus 2b upon root 2, 2 gone. So a plus b minus r. Why is it 2r? It's just r. I'm sorry. Yeah. Wait, bachcho. Yeah. Just a second. Yeah. So it's 6 is equal to 2a plus 2b minus r upon root 2. Right. So that's one relation. So that means 2a plus 2b minus r is equal to 6 root 2. That's one relation. Now see, one thing then I realized, one thing I didn't use yet, and that is the circle passes through the vertex C. And how can I use it? Just by using the distance formula. Distance of the vertex C from the center has to be the radius. So I just applied it, and that is 2a minus r whole square plus 2b minus r whole square is equal to r square, and that's it. Now 2a minus r from here. 2a minus r is 6 root 2 minus 2b whole square. Similarly, 2b minus r is 6 root 2 minus 2a whole square. And r square is how much? R is equal to 6 root 2 minus 2a minus 2b. So it's 2 common, 3 root 2 minus a minus b whole square. So that's 4 whole square. And then you can take 2 common from everywhere. That's gone. So now if you square it, and then we got the answer actually. Let's try it quickly. 18 plus b square minus how much? 6 root 2b, isn't that? Similarly, 18 plus a square minus 6 root 2 a is equal to a square plus b square minus 6 root 2a, 6 root 2b, and then plus 2ab. That's it. This gone, this gone, this gone, this gone, this gone, this gone, and this gone. So it's 36 is equal to 2ab, isn't that? So plus 18, yeah, there will be plus 18 also. 18, so 18. So ab is 9. That's it. So that should be the answer here. So the answer is 9 unit. That's it. So those were the questions for the chapter circle. Now next we'll be doing it for integration. As I said, after circle now we will complete the integral calculus, integration, definite integration, area, differential equation, moving to vector 3D, and then of course probability. Then we will come back to our conic section, and then to our calculus, the differential calculus. But that's how we have planned to proceed. Okay, so chaliye, let's end it. We will be coming with the next video solution of indefinite integral in the next session, bachcho.